If y is equal to f of x dy over dx, is the instantaneous rate of change. I explained last time how we go from delta y over delta x to dy over dx. The reason being we are bringing things closer and closer together on the x-axis to determine the change at a given instance. One thing to note is the derivative of a function. It is also a function. So even if you get a number as an answer, well, number y equals 2, for instance, is a horizontal line. A horizontal line is a function. But once we have this function, we evaluate the functions at different values. Yes.
May I ask you, just because at the very least, usually with the functions that we've been doing, if we're talking about terms of equivalent to y and stuff like that. With this, however, since we're putting y into the equation, how can we still consider this a function like f of x, where we're talking about that? Are we going to have it equal to some kind of third variable, such as h or z or something like that?
You mean calling this as something else?
Well, no, I'm just saying. So, for instance, when we're talking about the functions that we've been dealing with all of this semester, right?
Yes.
We've been dealing with functions where y equals to f of x. Now, if we're calling this a function, however, when it has two different variables, we're going to have, let's say z equals to f, one number comma another number equal to y and x inside of the credit coordinate. Does this work?
No, it's not going to be a coordinate. This could be defined as another function. For instance, I could call g of x to be equal to dy over dx, but I cannot use another y here, or w, or u, or z, any of those, because the moment you go from one variable to two, you're no longer talking about 2 dimensions. You're talking about more than 2 dimensions. So still, it is a function of one single variable. There is a notation that goes with dy over dx. Stands for y prime. Which is the same as saying f prime of x, which is nothing but dy over dx.
My main question is, and again, this is the original misunderstanding that I was trying to clear up. Since we have y in the picture itself, how exactly are we going to deal with that when it comes to solving, considering all the equations that we've been doing have just been where f of x is equal to y or g of x is equal to y.
Yes.
So are we, that's why I was saying, like, if we're going to use a variable and such, are we going to be trying to solve it, or are we going to try to solve for y prime?
We are going to solve for y prime.
Okay.
So when we take the derivative of y, we get y prime. What I'm trying to say is y prime is a function of x, and hence the answer is a function of x. What you've got to keep in mind is this could be changed, y and x, you could change it to y and t, s, t, doesn't matter. That is the dependent variable, that is the independent variable. You find the derivative of the dependent variable with respect to the independent variable. Does that make sense? You could change the letter, put anything you want, but you do have to keep in mind that this is dependent. Independent, and the derivative is always the change in the dependent variable with respect to the independent variable. Good. Well, I have a function, I take the derivative, I get y prime as a notation, which is f prime of x. This is also a function, which means I can take the derivative of this. Correct. What would the notation be? Take a guess. 2 primes. y prime prime.
Which is just where you do it. It's like it's good.
So that would be y double prime. So original function, take the first derivative, I get y prime, take the derivative again of the first derivative, you get y double prime, which would simply mean I'm taking the derivative of y prime. Yes, but what is y prime? Dy over dx. I'm just plugging in y prime. So trying to explain what's happening with not just giving you the notation. Well, what I'm about to mention is quite informal, but it's easier to understand. So the notation, if you multiply d and d, what do you get? D squared. So I could write it as d squared y dx multiplied by dx, dx squared. Good. Do we agree that y double prime could also be a function? Yes, it definitely is because it is a derivative. What should we call that? Prime, prime, prime.
Y triple prime.
Y prime.
Y triple prime.
Triple prime.
Our problems are the signs of our triple prime function. I don't know, try to look at that, it's not a good joke.
But the idea is the same. I'm going to take d over dx of the second derivative. So in terms of the notation, what would we get? Here, it was d squared y over dx squared. There, it has to be
D cubed y over dx cubed.
d cubed y over dx cubed. And I could keep on going.
With dx cubed at the very least being inside of parentheses, correct? So the dx within parentheses and then to the third power.
Yeah.
All right, so we've been doing.
I can keep on going and find the nth derivative. Right. Take the original function and find its derivative n times. So how many primes would we have? N, right? Let's say I'm taking the 100th derivative. Do you really want to write y prime prime time? No, you can, but kind of moronic. There has to be a better way. That is the formal way by all means when we do y raised within parentheses, I put n. If I see something like that in any textbook or article, I would immediately know that they are talking about the nth derivative. Does that make sense? Yes.
So how exactly is it that we're going to, I'm saying, how exactly are we going to specify between y raised, let's say the third power, or y raised to the 100th power or something, and y to the 100th prime?
The parentheses.
Okay.
If it is y raised to the 100th power, I'd simply write it as y raised 100. But when I say y within parentheses, 100th power, it simply tells me that it is the rate of change.
Okay, so difference between.
Do we agree with that last statement? This is the general way of looking at it. So if I plug in 1, that would become 1, so dy over dx. If I plug in 2, d squared over dx squared, that. If I plug in 3, d cubed y over dx cubed, and so on. But that is a very concise way of writing. If you go beyond and do differential equations and things like that, you will definitely see third prime or fourth prime in your equation. Good. Can I do this?
I just realized. You are.
Derivative of y with respect to x is f prime of x. From last time, we find the instantaneous rate of change by computing the difference quotient at the point x and taking the limit h approaches 0. Good.
I'll just write that or you can erase it.
When I say all limit laws, what I mean is, if you have two different functions, you add them together. We took the limit of the first function, limit of the second function, added them together to find the limit of the sum of functions. So all limit laws will apply to derivatives, but I do have to mention that some cases are tricky. In the sense, if you directly apply the limit law, the answer would probably be 0, or it would end up being an indeterminate form. So we've got to be careful, even though all limit laws will apply, some cases it is tricky unless you make some changes. We will encounter such a case when we get to product rule. Going to take the simplest function of all. What is the simplest function of all? Y equals x. Well, how about this? That is the second simplest function.
X equals 1.
X equals y.
Sorry, I didn't say word. That X equals 1.
X is equal to 1, close. Y equals 1.
Ah, my fault. Which occurs.
Right, consider y equals 1. Do we agree that that is a function? Yes, it is a horizontal line. Even before we get into the limit and me trying to explain the rule, if I asked you from a very logical standpoint, without even getting into the theory behind it, how does this y change with respect to 0? Excuse me, x.
Why not?
It doesn't, right? So since y is a constant is not going to change as you change x. In other words, is there a rate at which y is changing? Nope. Okay. If there is no rate, what is the value of that rate? 0. So
Delta y is equal to 0. And again, any number over 0 because delta x is still changing. X is changing infinitely inside of both ways, but in the case of 0.
in general, if I say f of x is equal to c, some constant, dy over dx would be equal to 0. I don't want you to simply memorize this. There is a reason as to why this is true. if f of x is equal to a constant c, what is f of x plus h?
Or just be C plus H.
It'll simply be c plus h, is it right?
Minus C, that's gonna be H over H.
That's one, but it's not one, it's zero.
No,
So Alejandro says if f of x is equal to c, f of x plus h would be equal to c plus h. Is it correct or not?
No.
No. What is it then? It's still c.
Why?
There's no X.
There is no x.
Oh, okay, well, you know what, that is correct.
Of course. C minus c is 0. Which will give you 0. So the reason I brought this up is to demonstrate that when we write these rules, they always go back to the limits. That's why we learn limits. I will do this for specific cases that are easy. Product rule and quotient rule, they do require some work, but I will explain that also. Can I erase? I want you to give an example of a polynomial or the next simple function, which you guys gave me credit.
Which is X equals 1.
X is equal to 1.
Oh, that's another simple function.
X equals 1 is not a function to begin with.
Oh, no, yeah, you're right, sorry.
The next simple function.
Sorry.
Y equals X.
I need some coffee this morning.
Are you sure?
I do, sincerely.
Y equals X.
Got it.
That is a straight line, correct? And do we know its slope?
Yes.
Yes, which is
1 over 1. 1 rise, 1 low.
the slope is 1, so we're saying for every unit increase in y, excuse me, in x, y changes by 1 unit also. So no matter where or what x point I pick, at this instance right there, what is the slope? 1. How about that?
1.
I guess you get the idea, because the order just dropped. So it's 1 everywhere, no matter where you look at this function. Great. What do you call that, an instantaneous rate of change?
No.
Why not, Annie?
Well, I mean, it's constant, so.
So I am finding the slope at that instant x point.
It's constant.
Could I call it an instantaneous rate of change?
So, yeah.
Yes. So simply put, for this function, dy over dx is 1. Right? Now what I'm going to say next is also informal, but easier way to remember. After understanding derivatives, you should not repeat this at all. The reason why I'm doing it this way is because I've seen students come to calculus 2 and not recognize what the derivative of y with respect to x is if y is equal to x. Imagine I multiply both sides by d. What would I get here?
dy with dx.
What would happen if I divide dx?
You would simply get dy over dx equals to 1.
Good.
There, lovely day.
But that's informal. What should the formal approach be?
Formal approach should be f of x plus h at the very least, plus, or not plus, sorry, minus f of x over h. And with the limit of h approaching 0. And that's at the very least, so we can just remove h once we factor everything out.
In other words, what he's trying to say is take limit h approaches 0 of the difference quotient of the function.
Yeah, but you do that.
What is f of x plus h? If y is equal to x, what is f of x plus h? 1.
Oh, we're saying at the very least, y is equal.
If y, which is f of x,
Oh,
is equal to x, what is f of x plus h, James? X plus h.
yeah, I am. Sorry.
Replace x by x plus h, so we get to x plus h minus x divided by h. Good. X and x would go away. H over h is 1. What is the limit h approaches 0 of 1? Limit of a constant.
0 over 0, which would be an indeterminate form if we're approaching 0.
Indeterminate form.
No, I'm just saying, if we're talking about.
Okay, we have 1 here. If h approaches 0, what happens to 1? Gets, well, h is getting smaller, but what about 1? It's a constant, so what would that equal to? 1. The limit h does not affect 1 at all because that is a constant. The limit's got nothing to do with 1, right? 1 is the limit, Lewis. Are we clear so far?
Yeah, my apologies. I think I'm gonna go straight to the derivative.
So
Are we
we're about to. So if y is equal to x squared, which is f of x, what should the curve look like?
Standard parabola.
If I can draw this properly, oh, I did a great job. Kind of. We want to find the equation of the instantaneous rate of change, which is going to give us an equation because the derivative is also a function, correct? So we're going to draw this tangent line. No matter where let's say I draw 1, it's a line, correct? If I move and drew 1 here, what would happen?
Maybe a different angle.
But is it a line? It's still a line. How about that? Still a line. How about that?
Still one.
Still a line. Here,
Still one.
there.
That's the whole point of the tangential line at the very least.
So no matter what point you pick on the curve, when you draw the tangent lines, at any given point, the derivative is a line, correct? What is the form of a line? The slope-intercept form, mx plus b. So when I find the derivative, I need to get a line.
It would be x.
No. So it will be of the form mx plus b. And I'm going to explain that in a bit, but I want you to find the limit h approaches 0 of the difference quotient for that function. Relatively easy. So we already agreed that the derivative is going to be a line. Looking at this picture, no matter where you look at the derivative is going to be a line. It has to be mx plus b of some form. It must have m, it must have b. And I'm glad that I asked you to do the difference quotient because you guys invented all forms of algebra. Very first week of classes, I mentioned something that's very, very important in algebra and calculus in general that would help you a lot, prevent you from making mistakes. Start with the letter P, parentheses. Right? You replace x by x plus h. Good. Minus the original function. What are the things that we expect to happen? The denominator h eventually will get cancelled. And there's another thing. The original function must get cancelled. So these are all the things that I saw. If this could happen, life is really, really easy, but they're not correct. The same thing as this, because this will come later on too. Don't make that mistake, not true. Because it is going to come back later. So, mistake. So how do we get it right? X plus h equals what? You foiled.
Yep, which is x squared plus 2xh plus h squared, which will then remove out the x squared from both sides, and then from there at the very least get 2xh plus h squared, you cancel out the h, and then you got 2x plus h. H begins approaching 0, and the limit will eventually become 0, so then you get 1 to 2x.
In simple terms, x squared will get cancelled. We will have 2x plus h squared divided by h. What do we have in common? H. If h comes out of 2xh, what would we have? If h comes out of h squared, what would we have? H. Those two got cancelled. Yes. And that would leave me with 2x plus h. Can't raise.
At the very least, that is what happened, everybody learns. Or relearns, depending on. I didn't count, remember?
We want to take the limit. Some of you got stuck here, maybe forgot, that's okay. And it's a Monday. H approaches 0. Would the limit affect 2x? No. Would it affect h?
Yeah.
Yes. So that would end up being 2x plus 0, which is 2x. This is what I meant when 0 was closed, but it's wrong.
Yeah, I forgot that you have to bring it
So-
forward.
I forgot it goes forward.
So 2x, do we agree that that is a line of mx plus b? What is m?
2.
What is b? 0, just like we expected. Now comes the best part. I made a case that, this works. In general, if you have x raised to the power of n, that is our function f of x. If you take the derivative of x raised n, this is what would happen. N is going to move to the front. And you reduce the power n by 1. So n minus 1. And this is going to work for all values of n. Good. So if you have x raised n would move to the front, and you have to decrease the power of x by 1. Most common mistake, you will move it to the front over here or back, depending on your perspective. So, but you'll forget to decrease it by 1. Okay. So n goes to the front, and you decrease the power of n by 1, always. Good. Let's go back to y equals x squared. Good. What is the value of n? 2. So I'm finding the derivative, so 2. X raised 2 minus 1, which is 1. And what is x raised 1? X. So the derivative is 2x. Good. Now, given the options, would you do that or this? Definitely this, because people have put in the effort and have shown that this is true. Just to summarize, derivative of a constant c is 0. Derivative of x raised n for any n is
G over dx with x then basically raised to power.
yes, all the time, but n.
Oh,
Nx to the power of n minus 1.
And x raised n minus 1. Good. There's one more rule. Now, I can easily prove this using the limit, but if you're interested, come talk to me, I'll show it to you. It involves something called the Binomial Theorem. Do we know what the Binomial Theorem is? No?
Familiar.
Okay. We would use Binomial Theorem to expand x plus h raised n, and then take the limit. And when you apply the limits, you would get n x raised n minus 1. Alice, oh, I got her name right. Do you know the Binomial Theorem? Don't remember, okay. Well, you can look it up.
Is that K or is that H? I just wanted to.
Yeah.
That's supposed to be n over K?
Haven't seen this before.
Yeah.
Long time ago. N choose K, that involves a factorial formula. Remember long time ago, maybe the second week when we did polynomials, I said, let's FOIL. And beyond x plus h cubed, you all had, wow, I had to FOIL x plus h raised. Go ahead, Nate, what did you say?
Pascal's triangle.
Pascal's triangle. Well, every single number in that triangle would correspond to this. So when I wrote 1, 4, 4, 1, 4, 6, 4, 1, so those would correspond to that particular coefficient. You can evaluate that directly using your calculator. So when we use this in our limit definition, eventually the original function will get cancelled, which would be x raised n. When you take the limit, there'll only be one term that will stay behind, and it is this term. And that's how we know the derivative of x raised n is n times x raised n minus 1. As I said, if you want to know more, come talk to me. Good. That leaves us with one more. E raised x. What is e?
E is the natural.
1 point something.
2.71828. Right? It is a number, but it is a natural number. But what do we mean when a function is e raised x? What is happening to the function as you change x? It goes up, right? In what way? Exponentially. So things are growing exponentially, right? If you look at a straight line, is a straight line growing exponentially? No. The growth is constant, which is why the first derivative of a line is just the slope. An exponential function is growing in an exponential manner. So if I asked you to take a guess as to what the rate of change would be at any given point x, what would your answer be? I don't know.
You gotta do it first, right?
Well, I can do the limit also, but I want you to use pure logic. Do you follow what I say? It's approaching linear function, constant rate of change. And if I say the population is growing exponentially, so what is the rate of change at any given point? What is its nature? Is it linear? Okay, Ali?
It's exponential at any point.
Right? If something is growing exponentially, it has to be an exponential at any given point. Do you agree? So the derivative of e raised x is e raised x.
Oh,
An easier way to remember, right? Exponential function, correct? Now I start drawing curves or straight lines. Doing a very poor job, but it's the best I could do. So the lines that are going up, what pattern are they following? The same pattern as the original function e raised x. So the derivative would also be exponential. So we looked at it logically, and we looked at it using a graph. I'll do the limit case for the last one because it involves a separate limit. So that's what we need to find in order to find the derivative of e raised x. Do we agree? So limit x h approaches 0, e raised x plus h minus e raised x divided by h. Okay. What is common between that term and that term? E raised what?
X. Times e
If
raised
e raised x comes out, it would become,
e raised to the power of h. And then that minus e raised x.
I took it out, so it'll be one.
Oh, I'm sorry. My fault.
If you remember, there was a homework problem like this. Do we? You should.
Did I ask you about it?
Yeah, exactly. Integral of a
Oh, yeah.
in his question, it was 5 raised x, right? So, which would simply mean that particular limit
Because we can take something like, let's say,
will go to 0. Excuse me, we'll go to 1, my bad. E raised 0 minus 1 is 0, and then 0 over 0. You can't put the answer as 0 because it's an indeterminate form. But this entire limit will become 1. So you would have e raised 1 times 1.
wait, how exactly would it escape becoming an indeterminate form? How exactly would it escape becoming an indeterminate form?
Do you have to expand e raised h, right? That's the erase and simplify.
So basically more mathematical.
There is more to this story.
Oh,
Okay, from here to there, there is more. I'm just getting that. If time permits this semester, I will get into indeterminate forms. There's a thing called L'Hopital's rule. That's very, very easy to do. Okay. Are we good? So those are the things you need to know